Welcome to Part 2 of the Introduction to Data Sufficiency from Chiron GMAT. Last time I introduced the DABC grid. This time I'll show you how to use it to solve problems. The solution method consists of 4 stages. One is to write down the givens, any information in the main body of the problem outside of statements 1 and 2. 2 is to write down the question, 3 is to write down the DABC grid, and finally 4 is to process the statements. The idea is to find the answer using a process of elimination. As you work through the statements, you'll cross out wrong answers on the DABC grid until all that's left is the correct answer. Let's give it a whirl with this problem. Here the top section says, each of the marbles in a jar is either red or blue. If a marble is selected from the jar at random, what is the probability that it will be red? As for the statements, the first gives us the percentage of blue marbles, and the second gives us the number of red marbles. Stage 1 is to process the givens, the information in this top section. So let's write G for givens and begin with this first sentence. Each of the marbles in a jar is either red or blue. Translating these words into math, we can say red plus blue equals the total number of marbles. Now we are ready for stage 2, the question. The question is this last clause. What is the probability that it, the selected marble, will be red? On our paper, we write Q for question, then P of red, which stands for the probability of red, equals question mark. This is a good start, but we can do better. There's a formula for this probability. If you can't remember how it goes, you can refresh your memory by thinking of a couple of simple examples. Say you have 2 marbles, one of which is red. The probability of picking a red marble is 1/2. But if you have a total of 4 marbles, 3 of which are red, the probability of red is 3/4. So, in general, the probability of picking red is red over total, and our question becomes red over total equals question mark. Next, stage 3 is to write down the DABC grid, and stage 4 is to process the statements. Statement 1 tells us that 75% of the marbles are blue, so we write 1, 75% are blue. The question is about red marbles, so let's see what we can infer about them. We already know that red plus blue equals total, so if 75% are blue, then the other 25% are red. This last line answers the question. We have found that red over total equals 25%. So statement 1 is sufficient. Now that we know statement 1 is sufficient, which answer choices can we eliminate? Let's enlarge our DABC grid to think about this. Remember that in these labels, the word hero means a sufficient statement. D might be the right answer. Double heroes means each statement is sufficient. So D accepts that 1 is sufficient. A is also a possibility. Saying that 1 is the lone hero means this scenario, so A correctly asserts that 1 is sufficient. In contrast, B, C, and E are mistaken about statement 1. B is wrong because its claim that 2 is the only hero describes this scenario, in which 1 is insufficient. And finally, C and E are the answer choices without heroes. According to them, neither 1 nor 2 is sufficient. But in this problem, 1 is sufficient, so C and E are wrong. Anytime we start with statement 1 and find it to be sufficient, we get to cross out B, C, and E in one fell swoop. Now that we are down to just 2 answer choices, we could just guess and have a decent chance of being right. There's a lot of time pressure on the GMAT, so if you find yourself running behind schedule, making a guess between 2 options can be a good way to catch up. Since we have time, let's tackle statement 2. It tells us that 6 of the marbles are red, so we write 2, red equals 6. The question is asking for the value of red over total, but we only know the number of red marbles. Without also knowing the total number of marbles, we can't answer the question, so statement 2 is insufficient. What does this mean for the final answer? Let's grow our DABC grid and find out. We have discovered that statement 1 is sufficient, while statement 2 is not. In other words, 1 is the lone hero, so the answer has to be A. Looking back at our solution, we invested quite a lot of time in writing out the givens and the question. Sometimes students are tempted to skip this groundwork. What's the point, they wonder, of copying what's right there in the top section of the problem? Well, the things we really needed to solve the problem, the equation red plus blue equals total, or the fact that the question is about red over total, are not spelled out in the top section. We had to dig these things out, make them explicit, so that we'd have the right framework for assessing the statements. And with that, we are all done with this problem. Before finishing up this video, let's tackle one more problem. This time, the top section says, a horizontal stripe of uniform width is painted around the circumference of a cylindrical coffee table, as shown above. What is the surface area of this stripe? Statement 1 tells us that n equals 1. In the diagram, we see that n is the width of the stripe. And finally, statement 2 gives us the area of the top of the table. To solve this, we start by writing out the givens. In this problem, a lot of the given information is in the diagram. That's typical of geometry problems, so anytime you see a geometry diagram in a GMAT problem, you should copy it on your scratch paper as part of the givens. Make a nice big copy, because you'll be adding detail to the diagram as you work through the problem. Stage 2 is to process the question, which says, what is the surface area of this stripe? Our first stab at this can be to write Q, area of stripe equals question mark. But let's try to figure out a formula for the area of the stripe. To get a clearer feel for the stripe, let's imagine pulling it down like this. The area we want is the dark outside of this band. It's easier to think of the area of a flat object, so let's imagine cutting the band vertically and laying it out like this. This flat shape is a rectangle, and the formula for the area of a rectangle is length times width. We already know that the width of this band is n, but what about its length? The length, which I'll trace here, is the same as the circumference of the band, which I'll trace here. These quantities are the same because the rectangle is just the band laid flat. And since we are talking about a horizontal stripe on the cylinder, the circumference of our band is the very same thing as the circumference of the cylinder. Thus, the length of our rectangle equals the circumference of the cylinder, and the circumference of any cylinder is 2 pi times the radius. So let's label the radius r and mark the length of our rectangle using the circumference formula 2 pi r. We can now see that the area of the rectangle is 2 pi r times n. So in our question, let's replace the words area of stripe with this formula. Of course, 2 and pi are constants. The unknown part of our formula is r times n. That is the missing information needed to find the area of the stripe. So let's simplify the question by focusing on this missing information and ask r times n equals question mark. Next, stage 3 is to jot down the Dabsey grid, and stage 4 is to process the statements. Statement 1 says that n equals 1. That's pretty straightforward, so let's just copy it as it is. Notice that the question is about r times n, whereas statement 1 only gives us n. This makes statement 1 insufficient. It's a good idea to check whether our results make intuitive sense. For geometry, this kind of check can mean imagining how the diagram can stretch. Let me zoom in and show you what I mean. We have concluded that n, the height of the stripe, is insufficient to determine the area of the stripe. So let's imagine what happens to the stripe if n is fixed but the radius r increases. The stripe gets longer, increasing its surface area. If we shrink the radius, the stripe gets smaller again. So this visualization confirms what we thought. N is not enough to compute the area. Before we move on to statement 2, let's enlarge our Dabsey grid and eliminate some wrong answer choices. In our previous problem, we crossed out B, C, and E because statement 1 was sufficient. This time, however, statement 1 is not sufficient. So instead of eliminating B, C, and E, we'll do the opposite, strike D and A. Looking at this in more detail, D is wrong because it says each statement is a hero, when in fact statement 1 is not a hero. A is wrong because it also makes the false claim that 1 is a hero. On the other hand, B remains possible. When B says that statement 2 is the only hero, it acknowledges that 1 is not a hero. As for C and E, they both say that neither statement is sufficient, so they are right about statement 1 and thus remain possible. And now, let's think about statement 2. It says, the area of the top of the table is 9 pi square feet. We can start by writing 2 area of top equals 9 pi. But let's try to express the area in terms of a formula. Looking at our diagram, the top of the table is this circular region. The area of a circle of radius r is pi r squared. So in our equation for statement 2, we can replace the words area of top with the formula pi r squared, and then just copy the rest of the equation. Notice that there is a pi on each side of the equation. If we divide both sides by pi, we get to cancel out the pi's. What's left is r squared equals 9. This equation has two possible solutions. R could be 3 or -3. But the radius of a circle can't be negative, so the only solution in this context is r equals 3. It's great that statement 2 has given us the value of r. However, this is not enough to answer our question, which asks for the value of r times n. So statement 2 is insufficient. Once again, we can use a visualization to check our results. Let's look at our cylinder and imagine what happens to the area of the stripe if its radius r is fixed, but its height n changes. If n increases, the stripe gets larger. If n decreases, the stripe gets smaller again. So we were right to conclude that the single variable r is insufficient to determine the area of the stripe. Now that we have a verdict on statement 2, let's blow up our Dabsey grid and eliminate some answer choices. B is the one that says 2 is a lone hero. Clearly that's wrong, because 2 is insufficient. On the other hand, C and E are still possible, because they both say that the individual statements are insufficient. So for the moment, we can only cross out B. To make our final choice between C and E, we need to combine statements 1 and 2 into a united statement U. The question is asking for the value of r times n. Statement 2 gives us r, and statement 1 gives us n. Putting these together, we can now say that r times n equals 3 times 1. This answers the question, so the united statement is sufficient. Let's enlarge the Dabsey grid one last time so that we can pick the final answer. We have seen that statements 1 and 2 are only sufficient together, so the answer is C. All right, with that, you have reached the end of this presentation from Chiron GMAT. Do come back and join us for the third installment of our Introduction to Data Sufficiency.